So, without further ado, our first speaker is Tomas. Tomas is a researcher that studied the consequences of strict ROA validation. So Tomas will tell us whether the RPKI is worth the juice. So, Tomas, you can share our presentation with us.
And I'm going to share the document. Okay.
Tomas, could you speak a little bit louder? We can hear you.
Okay. In the meantime,
all right.
I'm going to share one experiment. Basically, one experiment that studied the consequences of ROV deployment in a safe environment of simulation. The idea was to take real traffic from a network and simulate what would happen if ROV is deployed in the network. And before that, when my presentation is on, which is now still converting, I'm going to speak about basically the points that led to starting this study, or to beginning with this effort. So first of all, I hope, can you all see the presentation now? Hope so, yeah. Okay, thanks for yes. So first, I suppose you have seen this chart. It's from RIPE NCC, and it shows how many ROAs are present in public repositories. It translates to 10 or somebody says that I'm not easy to hear, so maybe I can try to adjust mic settings. Okay, your audio is fine, so hopefully it was either intermittent or not a global problem. So back to the chart. It translates to 15% of all prefixes in the internet are covered by ROAS currently, or it's maybe over 15%, which is good news. But the bad news is that actually it looks like that ROAS are not being validated, which means that, okay, there are ROAS, but nobody actually enforces the information in the ROAS on the real routing. And there are actually experiments. One experiment is mine. It has been published as a scientific paper, and the wrap-up is that actually we have found only 2 autonomous systems that are actively enforcing ROAS, and we have some set of let's say 10 or 12 autonomous systems that we have been able to find, and that looks like that they are likely to enforce ROAS, so or actually perform ROV. This is really disappointing because it's less than 0.1%. It's very much, very less than what would have been needed for actually doing something good for the internet and actually securing the internet. The point of the experiment was that we actually created hijacking scenario. As a matter of fact, we created 2 hijacking scenarios, and we tried to spot differences in prefix propagation or route propagation in BGP in the 2 hijacking scenarios based on different ROA status for the 2 hijacked prefixes. And the results are, as I said, and as I'm showing on the previous slide, the results are really disappointing. And actually there is another independent experiment that has been done by independent group of researchers, and they basically came to the same result, that ROV is not deployed to the point that it would make any difference. So the question is why, and there are obvious reasons that one can argue that are actually hampering, or that are actually causing low or slow deployment of ROV, or actually virtually no deployment of ROV. And among those reasons are, of course, concerns about a new technology, distrust in quite complex systems with cryptography involved and everything. And maybe the most important and the most, let's say, the reason that that has the largest merit inside is concern about disconnecting networks and losing traffic, because there are ROAs that are known to be simply wrong, because somebody created a ROA, then left it over, or changed configuration of the network, and then ROAs are simply not updated accordingly, which means that if the ROAs are being, or if somebody starts to enforce ROAs, then it would actually cause losing traffic. There are another reasons, like people argue that there is missing business case for RPKI, and there are some political reasons against, but I'm not going into these things. The important question for me is what are or what would have been the consequences of simply starting ROA enforcement in the current internet in existing autonomous system. So I created sort of, I actually tried to research this question, and of course there are statistics about conflicts between BGP and ROAs that actually shows how many prefixes would have been lost from global perspective. Actually, NIST is doing this, or did this research, and they have a web page, and I took these two charts from the web page that shows how many prefixes are actually covered and protected by ROAs, and how many of them are invalid. And yes, to Alex, ROV is the process of validating ROAs. It means root origin validation. These results actually show that there are several thousands of prefixes that would have been lost if ROAs are validated, or if the ROV is enforced. So the question is, what would be the impact on particular autonomous system? And that's the experiment that I did. The question was whether we can simulate it, and of course, answer is yes. I wrote a simulator, or I created a simulator. There is simple schematic or simple picture that shows what the simulator actually does. The point is that I'm running ordinary RPKI validator from RIPE. I'm getting the exported validated ROAs from the RIPE RPKI validator, and I am getting also BGP table dump from real or from live router in the autonomous system that participated in this study. And the point is that I can simply match them, match the ROAs to BGP routes, and I can find all prefixes that would have been lost or that would have been dropped because of ROAS or because of a conflict between ROA and BGP root or prefix which I get from BGP. I simply construct this list, and I use this list as a filter for filtering net flow. So the point is that I'm also getting net flow from the router and filtering the net flow to get only the traffic or only the flows that are actually coming to or from and going to prefixes that would have been lost, which means that in my output from the simulator, I'm getting simply flows that would have been lost, that wouldn't happen if the ROV is enforced. So let's have a look at the results. As you can see, it's starting under 1% for, sorry, maybe something is wrong with my pointer. Okay, as you can see on the left side, it starts under 1% for both TCP and UDP traffic. I actually split it, first of all, the flows for TCP, UDP, and other protocols. And from the middle section or from certain point, you can see slight elevation of lost TCP traffic for whatever reason. So I tried to analyze this and find what's wrong with the traffic in this period, because it elevates, it's higher for, let's say, 1.5 or 2 days, and then it's back under 1%. So I actually looked not only on TCP packets drops or it's actually number of percentage of number of packets which is dropped. So I looked at percentage of bytes or percentage of traffic volume, and it looks like that it's lower than it's below 0.5%. So the elevation is not that visible, though there is some elevation in the drop packets. To make long story short, I actually looked at the ports. It is not HTTP or mail or anything. It's in the group of others, and I had to manually look into the numbers, and the result is that it's some sort of Samba discovery thing, which is weird because the network in this network they have none or virtually none Windows servers, and further research actually proved that it was some sort of scanning attack that would have been actually prevented if our ROV is deployed. Actually, it's under radar attack. It does not break anything. It's not visible. It's several tens of megabits per second, or maybe slightly more, but it's not a big deal. The message is that simply these spikes, or the message is that I've been extremely lucky that I have been able to see this type of situation, that I started to simulate ROV, and the first thing was that there is impact under 1% on ordinary traffic, and if there is elevation, I was actually able to prove that it was an attack. And there is another thing, that's the same period, same graph, but it's only percentage of dropped packets based on ports. And on the left side, you can see a lot of drops, you can see intermittent drops up to 50% of packets going to or from port 143, which is IMAP, and that's another attack. I actually looked into the mail servers, and I've seen some weird scanning from addresses that are in the dropped set. So I was even more lucky that in that short period of simulation, I was able to spot these things. So that's I know that this does not prove anything about ROV globally, but I just wanted to share this experience that simulating ROV might actually make. Just to be clear, oh yes, that's right. The autonomous systems, autonomous system that that participated in this study was the AS2914134. And that's actually what I used as a source for BGP routes and a source for NetFlow routes. Sorry, source for NetFlow data from their border routers. And I just want to revisit this, the slide when I actually tried to summarize the reasons for not deploying ROV. First of all, concerns about the new technology. Oh yes, of course, but it's not that new because RIPE RPKI Validator is developed since 2011. Router supports RTR protocol for connecting to RPKI Validator for ages. And actually it's proven in the wild internet in several autonomous systems that actually explicitly stated that they are validating ROAS, that they are actually performing ROV, and it works for them. Though those autonomous systems are, though there is only a handful of them, of course, but still it's proven. When it comes to complexity of the system, I thought about it, and as for me, I would say that it's not as bad as things that we are completely happy to operate, like HTTP, HTTPS, or BGP. These things are maybe even more complex than the whole RPKI thing, and it simply works. Of course, concerns about disconnecting networks. Yes. Back to your question, Alex. I don't think that at this point I can say that these results hold for all autonomous systems. I think that the question is still open, and my aim is to actually invite more network operators, more autonomous systems to participate in this study. I know that it might be complicated because I need not only their BGP feeds, which might be sort of a problem for certain autonomous systems, but I also need their NetFlow, which is a confidential thing. So I'm thinking about making this possible. Like currently, I'm going to another slide just to explain what are my ideas about this. First, I want to make the ROV simulator more stable and more well usable, because now it's only a bunch of Python scripts and it's quite hard to use out of the box. It's simply a research project, so I'm going to rewrite it into C. It's now I'm now working on this, and when it is C application, it will be more effective and hopefully more usable. So any network operator will be able to run this in their own network, and if I'm lucky enough to invite more networks to participate in the study and share the results, I might be able to answer not only the question what would happen for the particular network or particular autonomous system, but also what would happen on a global scale. And another aim is to actually integrate the simulator with some intrusion detection system to automate the counting of prevented or possibly prevented attacks, and actually quantify whether the legitimate traffic that would have been lost and attacks that would have been prevented by ROV is different from sorry, is different from ordinary traffic that does not interfere or does not conflict with ROAS. And we might, I think that there are both possibilities open. We might see some difference or not. It's simply a question that is interesting for research purposes. Going back to previous slide, I wanted to finish with saying that it's not about persuading anybody to deploy ROV. I'm definitely not going to invent any missing business case for RPKI or solve the political problems that might be still an issue for ROV deployment. But I think that the most important question is whether ROV is doable and what are the consequences. And I think that this type of software could help network operators to answer these questions. That's all from me. And if you have any questions, I would be happy to either chat here in chat window, or you can just drop me an email. Especially if you are interested in this study, or if you might be willing to participate in this study, I would be happy to have a discussion with you. And if I have time, I can try to answer 2 questions that are here. Background. Oh yeah, of course. Autonomous systems that, or the one autonomous system that participated in the study. It's network. Sorry, it's hosting provider. They have something like 200 or 300 physical servers, and I don't know how many virtual servers, both their own and customer servers, but most of them are Linux machines, and well, yeah, it's basically content provider. There are no eyeballs, if I'm not mistaken, or maybe some small networks behind them, and basically their traffic is I would say that overall traffic is below 20 gigabits per second in peaks, which means that it's quite a small network. And when it comes to project, whether it's published in GitHub, yes, it is published in GitHub, and I'm sorry that I don't have a link in the presentation, but I will post it into the chat window in a second.
All right. Thank you very much, Tomas, for sharing your research. Are there any more questions to Tomas? Do you have a Twitter account, Tomas?
Well, not really, but I'm going to think about creating one, because yeah, that's maybe good idea. I'm not that good in you know, promoting myself on social networks, but I will definitely work on it.
All right. Thank you very much, Tomas, for sharing this with us. And yeah, let's move forward. Our next presenter is Stavros. Stavros is an engineer at Amsterdam Internet Exchange, one of the biggest internet exchanges in the world. Securing platform like that it's a challenging job. So Stavros, how you guys actually pulling that off?
Hi, good morning, good afternoon actually to everyone, and this is Stavros Konstantaras from Amsterdam Internet Exchange, and I work as a network engineer on the NOC Operations Center, and today we're gonna talk about implementation of RPKI and IRR security and filtering on the AMS-IX platform. So let's see the agenda first. It's quite busy. We're gonna start with AMS-IX RouteServers, where we're gonna show you quickly the architecture and the features. Later we're gonna jump into the most crucial, which is the filtering, and we're gonna talk about IRDB, RPKI, and BGP communities. And then we're gonna close the presentation with some real-life examples and problems. So let's start. Let's refresh a little bit your knowledge about route servers in IXPs. As you know, most of the IXPs outside use route servers as a very crucial part of the infrastructure. And route servers is actually nothing more than a commodity server which runs BGP speaker software. And the benefit of using a route server is that most of all reduces the number of BGP connections per member customer. So as you can see in the picture on this slide, we have the example of three members that they're going to speak BGP and exchange some prefixes between them. So every member has to establish a separate BGP connection to each other. But if we use a route server in the middle, every member has to establish only one BGP session with the route server, and then he can get the prefixes. So instead of establishing two BGP connections, establishes only one. And maybe for three members, the amount of BGP connections is not that great, but for AMS-IX, where we have 816 ASNs, so we have a lot of customers, that means that people can save a lot of BGP connections, and they can manage only the most important peers privately, and they can leave the rest of the work to the route servers. So also it's very useful, the route server concept, for the small networks, where they can immediately establish a BGP connection with the route server and receive and send routes immediately from day one. But also for large networks, they can use route servers as a backup. So you can have a private BGP connection with the peer, but also another one with the route server, and keep your IRDB and keep your database consistent. So in AMS-IX, the route servers are actually four. We have four commodity servers running Bird. And we have around 764 IPv4 peers and 612 IPv6 peers. Approximately, we received 267,000 prefixes, IPv4 prefixes, and 41,000 IPv6 prefixes. We also send a large amount of prefixes to the peers, but what is important is to say that we have an average prefix per peer is 375. For IPv4 and 72 for IPv6. What I would like also to note on this slide is that we do neutral prefix handling for all our members. So all the prefixes have a local pref of 100. We don't do anything special with the prefixes of some special members. Everything is the same for us. So a little bit, I would like to show you the architecture of the route servers in AMS-IX. As I said, nothing fancy. In the middle, inside AMS-IX platform, is just a commodity server which runs the Bird instance, and around that we have some custom software and some tools that are publicly available to everyone. And this route server actually is able to talk with IRDB or RPKI Validator from RIPE, and also we get some extra information from Team Kimru. So a member, as you can see, a member sends his prefixes, his community tags to a route server in AMS-IX. The software does the magic, filtering, and so on. We're going to talk about it in a few seconds. And then exports the prefixes to one of the members, or all the members, according to policy. So let's go forward. So the route servers in AMS-IX have the following features. First of all, of course, they receive prefixes and propagate the best path. They ensure that peering rules are satisfied. They perform IR and RPKI-based filtering. And we're going to talk about the 4 filtering modes. And of course, they perform community-based filtering. And one of the last things that they do is that they expose the information to Looking Glass and the notification system. I have an asterisk on the notification system because it's an upcoming feature. It's a work in progress. You're going to see it live in the next months. So I guess that you already have questions on what tools do we use inside to implement the route server concept in AMS-IX. We use quite some external tools. First of all, the Whois, right? Everyone knows Whois. It's about to read the member policy, which is written in RPSL language. We use BGPQ3 for resolving ASets. BGPQ3 is really good on that. It can also resolve nested ASets and provide us a lot of information. We use the validator, the RPKI validator from RIPE, to validate the BGP announcements from our peers. And of course, we use a lot of internal tools like the RouteServer configurator or the API for the RouteServer prefixes. So it's a big list, and I don't want to dive into that. We can discuss it offline if you want to. And now I would like to talk about the most crucial part of route servers, which is the filtering, and actually summarizes all the things that you learned up to this moment in this webinar. I would like to talk about prefix filtering in AMS-IX, which actually we divide it into different concepts. We have the basic prefix filtering, which is applied in the ingress, and the extended one, which is applied in the egress. So the basic prefix filtering actually filters Bogons and Martians prefixes, filters the default route, we don't accept it, and of course we do filtering of RFC 1918 ranges, so private LANs are not accepted within AMS-IX platform. The extended one is applied in egress, and where the customers or the members have the choice to select one of the 4 peering modes. We're going to discuss this in the next slide. Before I start talking about the filtering concept, I would like also to show you in this nice picture where we applied what. So as you can see in this picture again, in the ingress we apply the rules and we tag the prefixes. So when a member, as you can see from the left side of the picture, when a member sends us his prefixes with the community tags, we apply the rules and then we do the tagging. And then based on the configuration of every customer or every member, we apply the egress filtering, which is utilizing the IRRDB and RPKI. We're gonna talk about this now. So peering rules in AMS-IX. Prefixes that are not accepted and they're filtered in the ingress. As we said, Bogons and Martians. We don't accept, of course, advertisement of AMS-IX prefixes, right? We don't accept prefixes with AES path length greater than 64. That is not allowed. We don't accept announcements where the first AES in a prefix in AES path is not a customer one. And of course, we don't accept prefixes where the next hop does not belong to the router advertising the prefix. We don't accept these prefixes in the ingress and we drop them immediately. So we at the egress, AMS-IX applies the 4 filtering modes, which we're going to discuss this immediately. So the default one is to filter prefixes based on both IRRDB and RPKI. And another option for the members is to select filtering based only on IRRDB data, and another one is to select filtering based on RPKI data. Or if you want, you just receive all the prefixes with their tags, which is called just tagging option. So IRRDB filtering. Actually, as we said, the route servers they are configured using to have ingress filtering based on IRRDB, and the configuration is generated automatically based on some parser scripts that we use, and they parse IRRDB policies. The information is gathered from all major IRRDBs. We also check RIPE NCC's database, RADB, and from LACNIC, from all the big ones actually. And we try to detect the policy changes of the members every hour. Of course, we support the import via and export via features that is published in Draft Snyder's RFC back in 2015. And regarding the outgoing filtering, which is based on RR policies, actually when the members define the policies in RR database, actually you instruct the route servers what to advertise in the other members of the network. So please try to keep your IRR objects up to date, because based on your policies and what you advertise over there, what you have in RIPE database, actually the route servers behave accordingly. And of course, the peering modes are available in my AMS-IX portal, and users can select what they desire to, right? I have selected the last one, which is just tagging, just because to show you that this option is not recommended by us. and IRDB and RPKI data, both filtering modes are default one for us. So when you enable an AMS-IX link ID, we apply this filtering mode. So RPKI filtering, actually what we do is just the BGP announcements that we receive from our peers and members are validated with RIPE's RPKI validator, and we block all the RPKI, all the ROAs that have status invalid. As you can see here in this slide, I have included a picture from our RPKI validator, where in the first page you can see in the third row from the bottom that we have an announcement of a prefix where the AS number is invalid and the other ones are unknown. Just to let you know that the unknowns, we keep them, we don't ignore them or we don't drop them, we keep them because RPKI deployment currently is around 9% if I'm not mistaken. So we still keep the unknowns. The just tagging option, that is the last one, and as I said, is not the preferred one, is actually an option where we tag prefixes, the received prefixes, with some community tags that we define. You can also see these tags in our website. So when we have a prefix with raw status valid, we mark it with the corresponding tag, the same for invalid and also for the unknown. And the same happens also for IRDB filtering. So when we have a prefix announcement where the prefix is inside in AS or AS set of the member, we tag it accordingly, and also when it's not present. I would like to mention to all of you that these 5 options, right, is not the same. What I want to say is that we mark with 2 tags, one for the raw status and one for the either prefix is present or not present ES announced set. So we also do some BGP community filtering. So if you want, you can instruct the route servers to announce or not a prefix to other members based on some specific tags. So if you want, you can send a new BGP announcement with a specific tag with your AS number and the 0 or 6777 and your AS number, and the route server will propagate the prefix accordingly or not to the other members. This information is also on our website. I don't want to go into the details of that. But I would like also to mention that another security feature that the route servers have is the dynamic per AS prefix limit. This security feature that we have is developed in order to prevent route leaks. So imagine that suddenly some fat fingers or something happened due to misconfiguration of a network operator and start advertising a huge amount of prefixes. This can create a huge problem to the internet. There are stories around on the internet of use cases with that. So we developed this feature, and actually we keep it. We apply this limit dynamically because we have a lot of customers with small advertising small amount of prefix, but we also have some customers advertising a huge amount of prefixes. So we have to adapt the limits accordingly. We use IRDB to calculate the initial limits to you, and then there's an algorithm behind which is trained and observes your BGP announcements during the month and adjusts the filter accordingly. For customers setting only few prefixes, the limit is just 100 prefixes. But for huge customers, the maximum limit that we apply is 20,000. But as far as I know, no one has reached that limit yet. Another thing that I would like to mention is that all these options are available for us during the Policy Explorer. This is a new tool that we developed, and it's going to be soon available for our members. We use it internally. We monitor its progress. Looks very promising, works nice. You can see the picture here, how it's going to look like in my AMS-IX portal. And for example, for this member, we can see the export policies, we can see the prefixes, the status, the raw status of every prefix. We can see if the prefix is inside the RRDB or not. And as I said, this nice graphical tool is going to be in my AMS-IX portal soon for all the members. Some other functionalities that the route servers have is traffic engineering. Not many stuff to say about that. We have a feature which is called AS path prepending. So based on a community tag, we can prepend your AS number once, 2 or 3 times towards all other peers. This information is of course available on the website, and that can help many operators to do some traffic engineering and manipulate traffic through AMS-IX platform. I would like to close my presentation with with 2 actually real-life examples and problems which occurred in the past, which can show to us that things could have been prevented if we had the tools that now are available these days, and one of that is of course RPKI. So the first example is of a customer of us who created a big outage back on March of 2011 because that customer loaded an old configuration to his new router, and suddenly he started announcing the old AMS-IX prefix in a more specific, and actually the ASN number was not the AMS-IX peering LAN ASN, and that created a huge problem to the AMS-IX platform because suddenly all the members, all the peers started sending traffic towards to this member. Of course, if we had RPKI back then, it would be very useful for us to prevent that, and actually for everyone, because the ROA was not would be invalid, right? And the routers would have disregard the BGP announcement. Also, another example of that we had in the past, not very old, but on that days we had the RPKI in place. It's just a classic prefix hijacking where a member started advertising the AMS-IX peering LAN prefix in a more specific. It was a /22 instead of /21. It was announced by ES-XXX. The upstream was CPC, and of course that looks pretty clear in the ES path. But RPKI detected successfully that problem, and the raw status was correct. It clearly showed to us that the validation failed because of not correct origin. It expected 1200. It was something different. And then when you have these mechanisms in place, you can immediately contact the guys, the network operator of the other company, to try to fix it as soon as possible and not create further problems. And that is the end of my presentation. And of course, if you have more questions, I can happily accept your questions by email to me or to Aris, who is the security officer in AMS-IX and knows also the concepts of that.
All right, Stavros, we had one question to you during your presentation regarding your ingress filtering. Can the first AS be one that is in the customer AS set, but not the customer own AS?
Yes, I think I have it somewhere behind. Yes, according to that, let me go back. Yeah, the first AS in AS path is not the customer one. This is one of the rules that we apply in AMS-IX platform.
Okay. All right. So it looks like we got to the end of your session. Thank you very much for sharing it with us, and let's move on forward. Our next speaker is Pierre. Pierre is a network manager with particular interest in network automation. Peering platforms, as you've heard through the experiences of Stavros, are hard to secure due to large scale layer 2 domain and just a random number of participants. So Pierre built a tool to automatically build feature-rich configuration for BGP route servers, and we would be really keen on hearing about it. So Pierre?
Okay, can you hear me? Okay.
Pierre, we
Yes,
don't
yes.
hear you.
I just unmuted
Oh,
behind
yeah,
me. Okay. Hello, and so I'm Pier Carlo Chiodi, and I'm going to talk to you about a tool that I am recently developing during my free time, and which is focused on route server automation. And so we know that route server are brokers. You connect to them, you announce then your routes, and they redistribute your routes to all the other members that are connected as well. And usually route servers bring many benefits to the Internet Exchange Point members and also to the Internet Exchange Point itself. Members who connect to the route servers can receive a lot of routes and possibly exchange a lot of traffic by configuring and maintaining only one BGP session. But there could be also some drawbacks and some reasons to avoid connection to a route server. For example, they may represent a single point of failure that could lead to traffic blackhauling. For example, in the case of data plane failure that impairs the path between two clients, but not the path between the clients and the route servers themselves. And networks that perform fine-grained traffic engineering may also, I believe, undesirable to connect to the route server. And last but not least, network operators may believe unsafe to offload part of their network's routing intelligence to a third-party component. And why? Because sometimes route servers do not perform filtering or validation of the routes they receive from and eventually redistribute to their clients. So, okay, I connect to the route server and I receive a lot of routes, but are those routes actually good, or do they poison my routing table? And here in the slides I included some examples of routes that are unlikely to be found on a healthy route server. So the IS trans IS number, the IS path, or for example a private IS number. And well, with regards to this topic, there is also a nice tool that is maintained by Job Snyders and Samer Abdelafetz that shows how well Internet exchanges are doing in terms of secure route servers. The URL is in the slide. And another argument is about the propagation control over the routes that a member announces to the route servers. Generally speaking, if a network decides to join an Internet Exchange Point and to connect to a route server, it's because they agree to be reached by other members via the peering LAN. But if for any reason they need to avoid that a specific prefix reach one member or more member, well, the route server should allow them to implement this kind of policy. So the tool that I will present here, that is ARouteServer, is an ambitious project that I am developing during my free time, and whose goal is to help Internet Exchange Point to automatically build as secure as possible and useful and trustworthy configuration for their route server. And it is a command line tool, and it is written in Python and powered by the Jinja 2 templating engine. Of course, it's an open source software, and you can find it on GitHub. Of course, everyone is welcome to contribute to it. And currently, it supports both BERT and OpenBGPD, even if with some small limitations for the latter. So let's see how it works. This is a general picture. At first, the general policy and the list of clients are configured using two YAML files. The general policy outlines all the features, filters, options that in the end will be included within the configurations built using this tool. And an example can be found in the left box on the left side of this slide. And the list of clients, of course, represent the set of the members that are connected to the route server and all their details, things like the autonomous system number, the IP addresses, and the IS macros, and so on. And optionally, also some client-specific settings. And then some external data sources are used to gather additional information that in the end will enrich the final configuration of the route server. For example, IRR databases and also other sources are queried to get the list of prefixes and IS numbers that, starting from the IS macros that have been configured for each client. And PeerDB is also queried for the max prefix limits and the IS macros of the clients. And RIPE JSON files can be used to build the list of clients automatically. In the end, the route server configuration is automatically generated by my tool, and here our route server stops, and it's up to the Internet Exchange point staff to build a script to validate and deploy the configurations to the production route servers. Now let's talk about the policy and client configuration. So, as I already said, policies can be configured on a global scope using a vendor-agnostic syntax. And all the clients inherit their settings from the global policy, but they can also be configured using client-specific settings that, in that case, override those inherited from the global configuration. And this allows to have fine-grained control over the configuration of each client and also to handle corner cases or exceptions. And the list of clients can also be automatically generated using RIPE JSON files like those exported by the popular XP manager. And again, since every Internet Exchange point is different from others, and they may desire to have custom behaviors or functions implemented in their route servers. So I planned some hooks that can be used to inject custom snippets of configuration into the main configuration built using my tool. So this allows both to have all the benefits and features offered by the tool, and also to implement the custom behaviors that every Internet Exchange point may desire. So let's talk now about all the security features that this tool allows to implement in the configuration of route servers. Of course, most of the features offered by this tool are security-oriented, while others are let's call them sort of services that can be offered to clients. Almost all are optional and can be turned on or off by the route server operator. And with regards of the routing security, kind of a layered approach has been used, where each security mechanism adds more value to the previous one and contributes to reach the final goal, that is a better security, a better routing security and routing hygiene. And we start from the fruits like the max prefix limits, for example, that can be fetched from PeerDB, and we move up to IRR-based filters or also RPKI-based validation. The glue that puts all these layers together is the automation that allows also to make things easier for the operators, and also to avoid or reduce the human mistakes. So we have next stop enforcement, you know, to prevent traffic diversion, and this feature allow to be sure that the next stop attribute of the routes received by the server are set to one of the IP addresses that are actually used by the announcing network to join to the internet exchange point. It can be configured in strict mode that enforces the next stop to be the same IP address of the announcing client, or it can be configured in same AS mode. That allows the next stop attribute to be any address among those used by the announcing network to join to connect to the internet exchange point. This is useful, for example, for networks that have multiple connection to the same internet exchange. And also we have Espace sanitation to be sure, for example, that who is moving the slide here? We have I was saying yes, Espace sanitation then allows to be sure that the leftmost IS number in the Espace is the one of the network that is actually announcing the route, and also it allows to drop routes that carry private or invalid IS numbers in the AS path. And again, also a check on, let's call them transit-free AS numbers can be enabled too. This is to drop routes that carry the AS number of a transit-free network, for example, a tier 1 network, and in the middle of the AS path. With regard to the prefix validation, we have IRR-based filters, which are enabled by default, and they allow, starting from AS macros of each client, they allow to build a list of allowed prefixes and allowed original numbers that are in the end used to validate the routes that enter the route server. Of course, with definition of valid based on the data that are actually published into the IRR databases. And in addition to the traditional IRR-based filters, also a novel source for authoritative routing data has been recently added to the tool, and it is the HERINWIZ database. This database contains a field that is the origin IS that can be used by address space owners to declare a list of autonomous system numbers that they authorize to announce their prefixes. So the records that can be extracted from this database can be used as if they were RPSR route objects, authoritative route objects, and in order to improve the accuracy of the legacy ARR-based filters. And for example, Job Snyder, who operates the YYCIX route server for the Calgary's internet exchange point, well, they observed a substantial drop in the number of routes rejected because of the lack of a corresponding RPSR route object into the traditional ARR databases. And also, last but not least, RPKI validation can be enabled too. And a brief overview of some of the services that are offered to clients. And we have black hole filtering support, for example, with the optional next stop rewriting to allow layer 2 level filtering on the internet exchanges switches ports, and also route propagation control implemented using BGP communities, standard, extended, and large BGP communities. So things like announce to or do not announce to any member or to a specific member, and the same for prepending and so on. And lately also the support for the Graceful BGP session shutdown has been added to the tool, so that the Graceful Shutdown communities is honored and the local pref of the routes of the announcing network is lowered in order to allow the announcing network to perform some kind of maintenance in a safe way. And well, the full list of the all the features is reported in the GitHub page, or also in the documentation website. So in the end, hopefully all these features put together allow to have a trustworthy route server, and also hopefully have better global routing engine all over the whole internet. And the tool is actively developed and is used by some internet exchange points, both on Bird and on OpenBGPD. The good news is that the internet didn't melt down yet, yes, and more internet exchanges are approaching the benefits of running secure route server, secure configurations for their route server, and are considering to integrate this tool into their pipeline. Any feedback is very, very welcome and much appreciated. The source code can be found on GitHub, where you can also find some examples of configurations for both Bird and for OpenBGPD. That's all, and many thanks for your attention.
All right, thank you very much, Pierre. Are there any questions? I don't see any questions. If you're gonna have any, just type them in the chat window. Pierre is available here, right? You're not disappearing.
Bye.
And yeah, thank you very much, and let's move forward. All right. So our next speaker, we have to move a little bit. It will be David Freedman. David is an infrastructure manager at Claranet. So Claranet is a large managed service provider in Western Europe. So it's kind of going to another gear. How to secure kind of a network which is stretched between multiple countries and allows multiple connectivity. So how to secure this network. So David, if you're there, take it away.
Can you hear me?
We can hear you.
Excellent, that's really
All
good.
right, we see that.
I've just uploaded the document, so it's here we go. It hasn't done a very good job. Oh, here we go. That's good. Excellent. So I will. Oh dear, that's the zoom, not the next slide. All right, let's try and make that work at 100%, shall we? No, it's not going to work, so I'll have to scroll through it. That's not a problem. Right. So routing security at Claranet. So let me give you some background. We were established in 1996 as an ISP in the United Kingdom. So we've been around for 21 years, 22 years actually this year. We're a 2,000 person company, and we operate across quite a bit of Europe, where we have our own infrastructure, and also in Brazil, in South America. We're a managed services provider, which means that we essentially do ISP services that we manage for customers. So if you think about combination of providing internet connectivity, but also managing web applications and e-commerce applications. And as I said, we own our own network infrastructure in Europe, and we've built that infrastructure to supply these services. A little bit about me. I've been a network engineer for over 20 years. I'm an infrastructure manager at what we call the technology group. Someone's scrolling my slides. Whoever's scrolling my slides, when you scroll that, it scrolls it for everybody. So I've been network engineer for 20 years. I'm an arbiter for the RIPE NCC as well in my spare time. I'm a regular RIPE meeting and RIPE working group participant, and I'm also an IETF contributor. So I'm going to talk quite a lot about outbound security. So we practice something called manners. Go and have a look at manners.org, and that is basically set of principles to adhere to regarding security and collective responsibility for routing security. And as part of that, we do some very important things. We practice filtering on our BGP announcements. We have anti-spoofing techniques in the data plane, so we do source validation for outbound traffic from our customers. We maintain globally accessible, up-to-date contact information, and we publish our routing data globally, allowing others to validate what we do. I'll start with that one because that's pretty easy. So we're in peering DB, and if you take anything away from this talk, if you're an autonomous system on the internet that peers, you should really register it at peeringdb.com. It's been the de facto place to register information about ASNs and contact details for the last, good couple of years. So we publish all of our information about how to contact us and where our network's connected and how to reach us and all of those things on PeerDB. So that's for contact data, that's where we are. But we publish our routing data, which is obviously quite important, and all of our announcements are published really in the RIPE registry. I'll put Brazil aside for a moment because we're largely in the RIPE NCC service area. We publish our routing policies in our autonomous system object, which I'll talk about in a minute, and our origins routing statements are all rolled up. You can get to them through our AS Claranet macro. And we also publish rowers for all the prefixes we maintain, and of course we use the RIPE NCC managed RPKI, which is very easy to use and is a point-and-click system. Talking about publishing our routing policy in the ARouteNum, we do use RPSL to describe how we interconnect with peers and customers. We are very granular and verbose about how we do that. And we generate that automatically from our internal records, which I should point out is the reverse from how it was probably originally intended to be used. I think it was originally intended such that you would describe your routing policy in these objects and then you could build router configuration, but we did the opposite way around. I want to point this out. This is not so important or relevant today, given the advances made in routing security, and I will leave the discussion of that to the next set of presentations that come after the break. But essentially, whilst a bit of a legacy, this is important for other networks that we peer with to determine, to get session consistency and get some understanding of how we're connected to our customers. What's more important is the fact that we actually maintain an up-to-date AS set, so macro, which contains a roll-up of all of the what we call our customer cone, which I think become an industry-accepted term, i.e. the subset of customers that we route traffic for. We actually on our engineering site have a detailed breakdown of our AS set, and we do some stats on it. It's very difficult to see, probably, unless you zoom in on the deck, but what we've determined from this is actually that there's a lot of there are hygiene problems with it, being that we may keep up to date the top levels of that tree, but as we get down towards the leaves, if the customers of the customers of the customers don't keep their information up to date, it means that evaluating this AS set produces lots of prefixes which may or may not be valid. So we have a really difficult task trying to get our customers to apply that hygiene downwards and down towards the leaves of the tree. But to give you an example, if you were to evaluate our macro, you'd end up with almost 3,000 prefixes, whereas our real advertisement on a day-to-day basis is only a couple of hundred. And the reason for that is not just stuff that's no longer valid, it's also stuff that isn't currently advertised but will be advertised at some point in the future if there's a change in routing. So there's a combination of things. We strive to keep that as tidy as we can at the top level, but as I've said, it's a challenge moving down the tree towards the leaves. We also publish, as I've said, rowers for everything we originate, and we use the RIPE NCC hosted RPKI. It's very easy. We have rowers for everything in our LIR. And any downstream customers that also have access to this system and RLRs, we tell them to do the same. And we do some validation of that in when we do origin validation. We automate outbound prefix filters based on our AS macro. What you're seeing here is diff in some of the router configs, and it gets automatically committed as a result of evaluating our AS set. Now, that's a kind of a delicate topic to talk about automated filtering, because it comes with the caveat that you need a number of fail-safes to make this work robustly in a large environment. And provided, you know, that you get that there are those fail-safes in place, the automation can be a very effective tool in making sure that your filters are kept up to date. But it's something we really believe in and we've invested a lot of time in doing. And there's actually quite a lot of open source tools that help you do this. We just talked about BGPQ3 earlier I think it's in Stavros's presentation. But the idea really is that there are plenty of tools that can walk through these macros and produce prefixes from them. We also obviously filter our customers, and when we do that, when they speak BGP or they publish their information, we build automatic filters in pretty much the same way. And anti-spoofing, as I've talked about, so we do BCP38, so we do source validation. Usually on single and multi-home networks, we'll use unicast RPF or ACLs on single home customers. And multi-home customers get ACLs, which are built automatically. And we do that at either the customer interface, but we also do this on the internetwork interface. So tools, peers, and upstreams will also put the same sort of filtering in place. Now, depending on the size and scale of your network, that may or may not be appropriate. You might not be able to do packet filtering on some interfaces at scale, depending on what the scale challenges are. For us, that's less of a problem, and we do that. So we build a dynamic data plane filter that also includes our customer cone and any sources of traffic that are authorized and required we need to transmit from the network are automatically built into that. And this is actually provable. So there's this thing, go and check it out, called the Spoofer Project by CADA. And they employ software that lets you submit test results from behind the ASN. And if we regularly check ours and we see that we don't have spoofing problems for it. And the validation of this is really important. It shows that that hard work has paid off. For peers, so this is complicated. You can do filtering. So if you use an IXP filtering RouteServer, like we've seen presentations today on, then great. But if you have bilateral sessions, this is really hard because you need to generate per peer filters. And that means that their data has to be published. You know, you could say that, well, if you don't have if someone's data isn't published, why should you peer with them? And that's a valid argument. They need to have at least a valid a macro or an alt num that you can extract prefixes from, and you build filters on it. And again, you know, if you're going to do anything in the data plane, which I'm not sure is such a good idea on the peering edge inbound, but you know, but on a per peer basis, you've got to think about scale. You can't really do it on upstreams. If you rely on upstream networks, it's specific route filtering is likely impossible. General solution for inbound is really, you know, permit everything by default and just deny bog on marsh and known bad networks. And you do this for routes. You can also do that for packets. It's really effective. Again, if you can put packet filtering in, even if you just deny the bogon or the Martian networks, you know, do that, especially on shared media. And obviously, don't forget to deny your own prefixes or packets unless for some reason you really need to accept them. Like, for instance, you think your AS will be partitioned at some point in the future. You want to protect against that. I would say you shouldn't, and you should always deny your own prefixes, but people will always have exceptions. Last thing I want to talk about is something called policy violations. Policy violations are usually where there are multiple parties that appear that have genuine announcements, but the traffic somehow flows against policy. Usually, these announcements cause a forwarding conflict, and by that I mean that somebody, for example, there's some peering relationship, and then somebody announces something more specifically because it's their traffic engineering policy, and as a result, traffic gets drawn and forwarded across a network where it wasn't intended to. You can really only detect these with good telemetry, like NetFlow, RESTflow, and analysis, and these things are really difficult to resolve because sometimes the traffic behavior is intentional, and you know, sometimes there's a technical solution to it, and sometimes there's a commercial solution to it. So, for example, it's an unintended consequence of a technical solution, and maybe the two networks need to do something commercially. And sometimes it can be resolved politically as well. So the partition of function at the edge really helps. So, for example, if you've got routers sitting in Exchange that are just dedicated to doing that. That can sometimes help you avoid these, but generally there's something to watch out for. And I've provided a link to a blog post that will explain these in more detail, but they're just something to bear in mind. Last thing on my slide I've got is questions, if anybody wants to ask me any.
So guys, if you have any questions, that's your chance. And for David, thank you very much for your presentation. There are so many moving parts in the edge of your network, how you're securing it, that it's a quite a bit of hassle, I see. What would you say, out of all those moving parts, what's the hardest for you guys to actually manage?
I think that the automated filtering is not difficult to manage, but if you assume that this is a place where you need reliable systems design, and anything going wrong here has the potential to have massive impact on your network and your customer base. So
yeah,
you really get your,
like having a special button saying, you know,
exactly.
is it everything okay? Somebody kind of doing double check.
I mean, we aspire to you know, to do things with safety and critical systems design in mind, but ultimately we get management buy-in through doing that kind of development with appropriate, you know, safety review. But that's one of the hardest. It's not a technical challenge; it's more of a political challenge.
Yeah. Exactly. All right. I don't see any questions. If there are gonna be, oh, hold on. Let me just double check. All right. I don't see any questions coming in. So thank you very much, David. And we'll move to our next speaker, Mauricio. Mauricio works for a network information center in Costa Rica. They operate the .cr.Costa Rica top-level domain, and also the Exchange platform, which is extensively playing around with RPKI since 2014. So Mauricio, where you are currently with your RPKI validation? You have to also enable your mic.
Okay.
All right, we can hear.
Testing 1, 2, 3. Can you hear me?
All right, so take it away.
Awesome. And can you see my presentation as well? All right. Looks like
Okay, Mauricio,
everything
we
is
see
in
your
place.
screen. Everything is okay.
Awesome. So, well, thank you very much. I'm very happy to participate on the Educa event today. So, as part of this presentation, as you mentioned, my name is Mauricio Oviedo. I'm from NIC, Costa Rica, and the idea is to share a little bit about our implementation of RPKI within our Internet Exchange Point, and also to discuss some of the points that will be important to consider both to deploy RPKI, for example, on an Internet exchange, and also some operational challenges that we can have. So just before jumping into the presentation, a little bit about NIC Costa Rica. We're a not-for-profit organization. Basically, one of our primary goals is to promote the development of Internet in Costa Rica and regionally. So we've been managing the .cr TLD, the top-level domain, since the 90s. And one of these goals, which is the promote the internet within Costa Rica, led us to start a very important project, which is the Internet Exchange Point, the National Neutral Internet Exchange Point, which we call CRIX. So there's the website, and then CRIX has been running for around 4 years so far. We have 27 members active, and then 4 CDNs, and we're basically located in San Jose, Costa Rica. We just have one site in this moment, and it's basically in downtown. We're also members of LAC-IX and EuroIX, and hopefully this will continue to help us to speed up the development of the IXP itself. So feel free to go to a website, www.crix.cr, so you can know a little bit more about CRIX. So jumping into the presentation, as I mentioned, I wanted to talk a little bit about the implementation process, where we are at now, what are the operational challenges that we are facing, and also what are some of our future plans. So implementation process. Basically, we decided to split it up in 2 phases, and that was especially to make sure everything was going to work correctly, and to have the correct timing to move between the 2 phases, the 2 stages. So the phase number 1 was to use our PKI as an information-only system, and then for our next phase, which was phase 2, we wanted to enable route origin validation. So when did we start with it? Basically, since the very beginning. When we developed CRIX, we started in July 2014, and at the same moment we started using RPKI. Basically, we use a draft on from IETF that was created especially for instruct other countries to develop RPKI. It was created by the NAP of Ecuador, so it was very useful, and we use it as a guide. And basically, what we did was to develop this informational-only system where we can basically know the status of the routing information within our members. So this system, this RPKI system, we configure it also with BGP communities so that we can announce the validity of the prefixes being received at CRIX. Basically, we use a route server or 2 route servers that where all the members connect. We don't have direct peering between the members. Everyone connects to our route servers, and that centralized source of information, of course, help us to develop RPKI quickly. So with these communities, something that we wanted to do was to provide a benefit since the very beginning from RPKI to our members, and it was very interesting that we not only we're monitoring the members' announcement and status, which of course lead us to a more clean routing table, but also to identify some problems between the members, where, for example, one member was announcing a old prefix from an old customer that was now with a different ISP. So we were able also to identify those kind of issues, and it was very useful for our IXP members so that they can go ahead and clean up some of the routing announcements and come up with a more sanitized routing table. And then since this beginning, since the first week, something that was very useful to deploy our PKI from scratch was to train our members. Basically, we did a workshop with the collaboration of LACNIC and ISOC, where we train our members on how to use RPKI, traffic engineering, and other technologies. And it was a big impact on the way RPKI was being managed in the country. Let me show you some graphs. For example, when we did the workshop, as you can see in the graphs, the sign prefixes with RPKI increased dramatically, and that's an excellent example on why training is that useful and especially is necessary in technologies like RPKI. Same thing happened with the coverage from ROAS, from IPv4, and the same increase can be seen on the IPv4 and IPv6 space covered by the ROAS. So basically, after this training and this initial phase, we were able to speed up the process. We had a close eye on the announcement. We worked together with the members, the IXP members, so that they can fix when it was needed the announcement, and especially to make sure that they were certificating every resource they had, that all the ROAS were correctly created, and then the certificates as well. So we got to the point where we needed to move forward. Basically, we got to the point where we said, well, RPKI, why not? As Natalie said at the beginning of this day of presentations, she pointed out that RPKI is not much of help if we don't validate. So that's exactly what we were thinking. We already had RPKI, the members were using it, we had a clean routing table from them, and then we were thinking why we shouldn't enable RPKI origin validation. We want to provide a higher level of security to our members. We wanted to promote manners, basically to be better internet citizens. So we decided to go ahead and basically start with origin validation on May 2015. That's around 10 months after the initial launch of CRIX. At that moment, we basically transitioned from this informational only system to the origin validation. During this transition, all the announcements started to be, all the invalid announcements started to be discarded at the RouteServer. The good news is that by then we didn't have any invalid announcements. All the work was done before. We worked with all of our members so that we had no invalid announcements. But still, all the transition was coordinated with them to minimize any impact. And then something that also was very important is that even though we already had a training and a workshop with all our members, we kept receiving new members to the IX. So one of the key points of having RPKI already in place is that as part of the setup of the new members, we included the ROA creation and validation. So basically, before every member starts exchanging traffic with in the production environment, we connect it to a testing environment, and we run several tests. And one of those tests is to make sure that the prefixes being announced are already with a correct ROA and are being correctly validated. So this also helps for new participants to not only connect to a secure
Hi everyone, Andrzej Wolski here. We kind of lost Mauricio. I'm not sure what is happening here. We have some of his slides, but we've lost the voice. Mauricio, maybe you can try, if you hear us, maybe you can try to switch off and on the video and the microphone. Yeah, you can hear us. We would like to hear you as well. All right. So let's try to, in the Adobe Connect, to switch off the mic and the camera. All right. We'll try to help you. And the rest of the guys, you can relax for a moment till we figured it out what happened here. Mauricio, maybe you've been using a USB microphone. Maybe you can just connect it and disconnect it. Sometimes it happens with macOS 10 that 15 minutes is the breaking point. Meanwhile, for all the others and information, after we're going to finish this session, Mauricio is the last one speaking in this session. We'll immediately jump into the next session where we're going to look at the future kind of development in this topic. So after this session, just bear with us, stay. There's going to be a very short break, about a minute or two, and we're going to move on to the next session. Meanwhile, how Mauricio is doing? Okay, we done. Mauricio, maybe you can just close the Adobe Connect and connect again. Maybe that will help. All right. So Mauricio was there, and he's no longer here. All right. So Mauricio will connect in the second. He's our last speaker in this session. Let's see whatever he's going to be able to connect back. No? No, Mauricio? Hmm? Right. It doesn't look like he's coming back. Oh, right. Mauricio is back. All right, Mauricio. Whenever you want, you can jump in. It should work now.
Okay, can you hear me now?
Yes, we can hear you. All right.
Okay, thank you. I really apologize.
No,
Not sure what
well,
happened,
it's
but
technology.
my application died. All right,
Happens.
so 1 second to share the screen again, and we'll be ready to go.
All right, so we are back.
All right,
Take it away.
so we're back. Awesome. So apologize for that. And what I was mentioning is that our current status is in IPv4. We basically have more than 1,000 of prefixes which are valid and 60 not found. And then on IPv6, we have 21 valid prefixes and 24 not found. So these numbers in one side tells that we need to do more work on IPv6. It's just around 45 prefixes, but other than that, something important is that the not founds are primarily DNS operators, especially root operators, and then CDNs and some end customers. So this is very important because since a while we've seen that especially big companies are not creating ROAs yet. Even DNS organizations that usually promote this kind of technology. So it's a good moment to motivate them to go ahead and create the ROAs, and at the end it's to protect their own routing. So not founds are primarily from them. And then something important is that we have no invalid announcements. Right now, every time we receive a invalid announcement, we address it immediately. Basically, we contact the members where we are receiving these kind of announcements and try to work it out as soon as possible. As of now, we have no invalid announcements. And so with the day-to-day, some operational challenges that we have seen are basically that not everyone knows about the benefits of having RPKI, and this sometimes delays the time where someone creates the ROAS and then that we can use it. As you will see, most of the operational challenges are related to people, and that's because of what we have seen on the common issues on the day-to-day. So another one is that sometimes the people which is authorized to use the RIR platforms, where you create the ROAS and the certificates, are non-technical. And sometimes, especially when creating the ROAS, this leads to the human error and sometimes not being able to or not knowing correctly how to set this information. Then we have also had challenges with regional IT departments where basically we have local connectivity, but sometimes we need to wait for having either the right contact or an answer from people from a different country, and that also sometimes leads to delays. So that's another one. And then this is new for most of the members. Almost every time we receive a new member, it's very common for them not knowing about RPKI. So it's important to highlight that this capacity building within RPKI needs to be continuous. It doesn't. It's not sufficient to do, for example, like in our case, a workshop at the beginning of the IX. We need to continue doing it. And this is also because the ISP techs, the technical people, also rotates. So even though they were trained at some point, people will be changing. So as you can see, most of the operational challenges that we are showing are related to people, and that's especially because all the problems that we have seen so far, or the incidents that we have managed, were related to misconfiguration on one of the member side or on the end customer's side. So that means that we need to continue providing accurate information, providing tools, providing different ways for the members or customers to be able to use RPKI correctly. So at the end, the challenge is how to promote this knowledge, especially the technical knowledge to be able to manage it correctly, but also the troubleshooting skills so they can know when something is broken and be able to resolve it quickly. So our future plans, we want to continue improving in the way that we use our PKI, and some of these plans goes in, especially in the automation of the detection and the notification of every invalid route we receive. As I mentioned before, right now this is a manual process, and being a manual process, of course, it's not as fast as it could be with an automated process. So we are working on it, and we expect to have it ready soon. Something that we are doing for that is that we are also working with BERT RouteServer. Right now, the route servers that we have are Cisco servers. So we are working with BERT still on testing phase, but it supports RPKI, and the idea is to provide more platform diversity to the IX, and at the same time to provide more options to be able to automate the system. Then we also want to collaborate with the non-IX ASNs from Costa Rica, the autonomous system numbers, which are not part of our IXP, but still that having ASNs, public ASNs, so that they can also deploy RPKI. And finally, we want to develop local workshops for project knowledge and updates. Then we have a wish list for our RIRs and ISPs. Basically, we think that it's very important to maintain, to keep, and to provide testing beds for ROA and certificate creation, so that new people can play around and also test different environments before going live on production, and that way minimizing the probability of breaking things. Then the other thing is that it will be interesting to have something where the RIRs can include, for example, information of the ROA generation or instructions as part of the initial resource assignment, and that way people, once they receive, for example, an IPv4, IPv6 block with information about the ROA creation, the ROA generation, we can speed up also the people who will be using our PKI. And to use it as an alternative for the letter of authorizations. It's basically if we know where are those announcement of prefixes coming from, that way we'll be able also to validate that information and remove sometimes the delays that are caused by these kind of authorizations, depending on the networks, of course. And then keep doing these kind of webinars, which are really cool and helps a lot to get a better understanding. So at the end, just summing up, in this implementation for us, in our particular case, was very important to choose a route server with RPKI support. Not all of them support it, so it's very important to keep an eye on it, especially if you are thinking on moving either to use route servers or to change the platform that you already have. So make sure that RPKI is supported. Then for IXPs, try to get the members involved since the beginning if you are starting with the IX, and if you are already on board, try to make them understand and to especially to transmit the benefits of RPKI so they can be part of the process and be collaborative on it. Then and in our case, it was very useful to split the process into phases, and maybe it will work for you as well, and keep training your local community. At the end, we think that it's very important to deploy our PKI. It's part of the way that we contribute to a better internet, and as a conclusion, we also believe that, as it was said in a previous meeting, 80% of the success of an IXP depends on creating an environment of cooperation, of trust among the members, and well, RPKI is one of the tools that we have to create that environment, and hopefully it will continue providing more security to the internet. So that's basically what I have it prepared, and I'm not sure if I have some time for questions, but at the beginning of the presentation, it's my email as well in case you want to reach me and keep discussing this implementation. Thank you very much.
All right. Thank you very much, Mauricio. Are there any questions?